Okay, so just to complete the option C in the Superlab one, just a couple of notes. So the first one is that our route reflector is running an older version of code and can't handle the 4-byte ASs. And it's on the route reflector that we type in peer AS 23456. So for P2.1 here, which we're calling P2 remote PE, this guy here, this is using a 4-byte AS. The route reflector isn't able to use them. So we type this in, and then what happens is the 4-byte AS PE accepts that as a neighbor, and it knows that the route reflector is running code that's a little bit old, and then an extra object gets added via the route reflector. So this guy knows that the route reflector is out of code, older code, adds an extra object, and then when it passes through to the next PE that is able to handle 4-byte AS, it just flips the 23456 back to the correct AS number. So finally, let's just go through the labels one last time. Okay, so when the packet's on the way from router 7 to router 8, heading towards CE2, the innermost label is going to be the VPN CE2, and the label in the middle is going to be the label unicast, which R8 has forwarded on, and then the label on the outside is going to be the standard LSP from router 7 to router 8. Obviously, as the packet, that's your 3-level stack. Obviously, as the packet arrives on router 8, the outer label is going to be torn off. And now you're going to have a 2-label stack, because from router 8 heading towards CE2, you're going to have the inner label, which is a VPN label, and you're going to have the outer label now, which is the labeled unicast. Now, P2 here is not only the ASBR, but it's also the PE that's heading towards the customer. So it's a little bit shortened, this example, but if P2 was just the ASBR, and if it was going to another either route reflector or another PE, then of course you'd have that third label appear again as it ran through any LSP that this ASBR may have.